Okay, so I just want to quickly get a bit of a review going for the last lesson because we covered quite a few ideas, and I think it's important that we just review them quickly. So who would like to tell me something they remember from the last lesson that may be important as we go towards trig identities and review today? What's one thing that stays in your brain from the last lesson? You can put your hand up if you like, and we can hear from you. It's nice and quick audio-wise. If you want, you can type it. But what stayed with you from the last lesson? Okay, Nomtanzo. What stayed with you from the last lesson?
Afternoon, sir.
Hey.
What stayed with me from the last lesson is that we were doing identities and sine theta over cos theta is equals to tan theta.
Love it. So what we call the quotient identity, that is a very important idea. Thank you so much. That is a great contribution. Let's go to Ayanda. Ayanda, what did you
Hi, sir.
remember? Hey.
No, I wanted to say what you said.
Okay. Anything else that stayed with you?
No.
No. Okay. That's fine. Tigabazzo, let's go to you.
Good afternoon, sir.
Hello.
I remember that our square identity is sine squared x plus cos squared x is equals to 1, and we can extend it to 1 minus cos squared x is equals to sine squared x, or 1 minus sine squared x is equals to cos squared x.
Oh, you're on fire. That's a tricky one. You're absolutely right. I didn't use x this time. I used theta, but as long as I'm consistent, that's perfect. Now, that was a lot. That was really useful. Because not only can I write it like this, sometimes I write it in this form. And sometimes I write it in this form. And so this is called a square identity, and it often comes up when we want to replace. We can replace either a 1 or we can replace a 1 minus cos squared theta, or we can replace a 1 minus sine squared theta with something on the other side. We also looked at how to prove, or when we prove an identity, we start with the left-hand side or the right-hand side and make it equal to each other. So that was something important. How to factorize in trig. Oh, you guys have, I'm so impressed. How to factorize with trig expressions. I like that. What other things have we got there? Trig identities, fantastic. And Umta, what do you have that you remember from the previous lesson?
Hi, sir.
Hey.
I was going to ask something, sir.
It's fine. Go ahead and ask.
Since sine squared theta is equal to 1 minus cos squared theta, right? Can't 1 minus cos theta equal to sine theta?
No, but it's a great question. Okay. So the sine, so you're saying, can sine of theta equal 1 minus cos theta? And the answer is, and this is important because it's a common mistake, is no, it can't. The only time it's going to work. Yeah, but it's a great question. Thank you for asking that. And it's such a good thing to show you how sometimes just pointing something out can really help the class on the whole. Because I guarantee you, some students, whenever I mark these papers, there'll always be some students who make this mistake because it feels right. But it's called the square identity because it's got squares in it. Okay, fantastic. I'm very impressed, and let's continue on our learning journey with trig. But huge shout outs to the class, really impressed. Let's start with a simplifying question. And someone mentioned this in the chat too. Sometimes you give expressions and you're asked to simplify them. I want to see, can you simplify this expression for me, just to get going for today? So over to you guys. I'll give you a minute to do that. Cool. So can you simplify this? Or if you have a question, just pop your hand up and I will do my best to make it clearer. Yeah, let's go to Mercy. Mercy, what's your question?
Hello, sir. How are you?
Hey, very good. And you?
I'm well. Sir, I'm struggling to find out, like with the cos x tan, sir, square.
Okay. So you're okay with the first bit, but then
Yes,
it's over here. So what I can tell you is that the relationship is a times relationship. So they're being times. But I think changing the tan squared into something else might be a good step. What comes to mind for you when you think of changing this this tan x here? What could you maybe change it to? I don't know if you can hear me still. I see it. Okay, so I think maybe lost you there, but what I was thinking is we can change tan x into sine x over cos x, but then that must also be squared still. Or we could say, so I'm going to change that bit into sine x over cos x squared. Give me a thumbs up in the chat if you feel like you understand what I did there. Give me a thumbs down if you feel like you don't. So let's go to Umta.
Sir, I was gonna ask you, is
Yes.
sine squared x over cos squared x the same as sine x over cos x to the power of 2?
Exactly. So again, you're on fire today. They are exactly the same thing, but let me just write them out like this. So these two, that they mean the same thing. So you can either write it like I did in blue here, or if you prefer, there's a couple of different ways you can write it. You could also write it like this. And that's fine, but even this can be rewritten a little bit. I can unpack this a little bit too, which I'll talk about in a moment. Let's go to
Okay,
Ayanda.
thank you.
Pleasure.
I know, sir. I wanted to ask the same thing.
Okay, so are we okay so far? Are you do you understand that it's the same thing?
Yes, sir.
Before you go, can I ask you something? I'm going to start on this next step where I want to have these two pieces interact. I'm thinking it might be easier if I do something to this block first. Do you have any ideas about how I can write it so that it's easier to interact with the cos x term next door? Any ideas that come to mind?
No, sir. I think you'll multiply.
Okay, you're absolutely right, you multiply. If I said this, would this still make sense to you? So I'm going to write something like that. Does that make sense to you, Ayanda? What I did
Yes,
there?
yes, sir.
Okay, why do you think I did that?
I think we are going to cancel the cos x.
Yes. So you can cancel those two cos x's there, yes. Oh, Annie's asked, why can't we take out the common factor? Annie, I think we probably could have. So let me actually, I didn't even think about that, but I'll show you how we can get the same answer in both ways. So what we have now, in fact, you know what, Annie, I think that probably, if I cancel this out, that's fine. I've actually made it more complicated than it needs to be, but let me just let me finish it like this, and then I'm going to go back and actually do what Annie suggested there. So I have sin squared x over cos x. Okay, everyone, I know that this is getting a little bit sneaky tricky, but are you okay with this blue block here? And I'm going to show you another way of doing this, but it's a good exercise to go through anyway. Thumbs up if you get how I got to the blue block. Thumbs down if the blue block confuses you. Okay. Okay, so there's quite a bit of uncertainty here. So I'm going to show you how we could have done it a different way, and then I'm going to show you how we can get to the same answer with the process that I've just taken now. Okay, so the blue block is paused over here, and it is, I'm going to come back to that in a second, but what I'm going to do is another method we could have done, and Annie pointed this out, is look at how there's a cos x and a cos x here. What we could have done instead is we could have said cos x 1 plus tan squared x. Yeah, I don't know if that really makes it much simpler if we're going to simplify it. So this was Annie's choice in terms of, or her suggestion. But the problem is, Annie, can you see now that I've factorized it, how do I make it any simpler? So if I take out this common factor, it's all good and well, unless I could, well, you know what I could do is I could convert this into sine squares over cos squares and stuff like that. But that's all going to take me a while. So even though this method could work, because I've done quite a lot of work here already, I'm going to carry on with this bit here and just say that it's not wrong, I need to do that, but then you need to start the process of converting the tan squared x. Okay, let me go back to this blue block here. I would really like to put these two terms together. So I want you to put this term over here and this term over here together. What do we normally have to do if we want to add two fractions? Any ideas when we want to add two fractions? Yeah, let's go to Annie.
Hello, sir.
Hey.
Hi, sir. So I just wanted to ask, with the method you're doing, right? The second step that we did, why didn't we cancel the other costs, the one at the bottom and the one on the left-hand side?
Okay, the problem is that this cos x is a separate term, and so we can't touch that cos x over there because it's separated by the plus sign.
Okay, sir.
Okay, but we try and stick these together. Now, what I was going to say, everyone, is normally when we add fractions, we normally have to have a common denominator. So would you agree with me that this common denominator should be cos x? Because I got 1 in cos x, and to get that, I need to multiply this by cos x, and I need to multiply this by cos x. So I've multiplied the top and bottom by the same thing. Now, if I do that, I'm going to get cos squared x plus sine squared x or cos x as my next step. Give me a thumbs up if you understand how I went from there to there. Give me a thumbs down if you feel a bit lost. What I've tried to use is the common denominator. Okay, we're going to go nice and slowly here, and we're going to carry on practicing this for the rest of the lesson. So I know y is the numerator cos squared. So let me show you like this again. So if I have the number or the term cos x over 1, if I times the top and bottom by cos x, does it change the value of the fraction? No. If I times the top and bottom by 2, it doesn't change the type of fraction it is, but it does mean that it then looks like this. Now, why would I want to have a cos x at the bottom? Why would that be useful? Why would it be useful to have a cos x at the bottom now? Does anybody have an idea? So wouldn't it be because, and I'm going to rewrite the other term. So we had the other term and it was sine squared x over cos x. The reason it's super helpful is that now both of the denominators are cos x. So that's how I got this cos x over here. But then look what's on top. On top is cos squared x, and over here is sine squared x. Can we have another quick vote? So thumbs up if you understand how I got to that step. Thumbs down if you feel still quite confused there. I really did choose a toughie today. We're almost done with this one. Okay, Umta, let's go to you.
Sir,
Yes.
what's the step in green?
The step in green. The step in green was, I was just going a little exploration on a method that, so Annie suggested, why don't I take out the common factor of cos x? And so I was just showing you it's possible to do that, but then you're going to have to then go down a different path. And so I decided to leave that. It's because of time. I'm not going to explore every possible method today.
Okay, thank you, sir.
All right, let's finish this question off. What's going to be the last step that I do to simplify this? What's going to be the last step that I do? What's special about cos squared x plus sine squared x? Okay, Umta, what did Umta, let's go to Umta. Umta, what do you think special about cos squared x plus sine squared x? Oh, I see in the chat it's lighting up.
Because it's equal to 1 over
Yes.
cos.
Okay, now that was quite a journey, ladies and gentlemen, but it turns out that that whole thing can simplify to 1 over cos x. Now, I'm going to move on from this now because I don't want to spend the whole lesson on this question, but I do want you to go over the different steps that I used. So I replaced, so step 1 might be like, I replaced it, then I canceled some things out, then I created a common denominator, and then lastly, I did another replacement. So it's about a 4 or 5 mark question. Okay, Haruki, do you have a question you'd like to ask?
I wanted to ask if, because both of the denominators are cos x, can't you just cancel them out?
Okay, you can't because you created the common denominator so that you could put them together. So you can't cancel them out because you literally brought them into existence to help you. So you wouldn't want them to go away. You'll see this again in the next couple of questions. So just hang in there and you'll see it again and you'll see why it's useful. Okay.
Thank you.
Cool. Now, what I want to do next
Peter,
is...
Mr. S.
Yeah.
We have a question from Ayana in the chat saying, sir, how did we get the cos x at the bottom?
Okay.
I think
So,
the colors.
yes. Okay. So what I did was I got stuck at this. Let me take this out. I got stuck at this stage over here. So this big yellow bit, that's where I got to. And the problem is I couldn't add 2 because the one denominator was 1, the other denominator was cos x. So what I did was I forced it to have a denominator of cos x by timesing the top and bottom by cos x. And then basically I had this situation. Then if those denominators are the same, just write them down once over here. And then I just add the cos squared and the sine squared like that. So in Bali and Zanetta, it is possible to go the green method, but I'm going to say for today, that idea, we don't need to go down that route today. We've learned all we can from this particular example. And so let's do another one for the break so you can apply this idea. Okay, here is the type of question I want to do. This is a full proof question. So you need to prove that this thing, this side, the left-hand side is equal to the right-hand side. Now, whenever we do a proof question like this, we choose the more difficult side to work with. So do you think the difficult side is the left-hand side or the difficult side is the right-hand side? Tell me in the chat. Which side do you think is harder? I'm watching. I see some people have voted. Oh, the people of the class have said quite clearly that left-hand side is the way to go. So I'm going to write out the left-hand side because that is what I'm going to work with. And my goal in this type of question is to simplify the left-hand side to make it look like the right-hand side. Now, the right-hand side, to be clear, is 1 over cos squared theta. Okay, now, as a class, I want to ask, what do you think? In fact, I'm going to give you 60 seconds to try and think about what do you think my first step is going to be. And once you've thought about it, I want you to put a description in the chat of the step you think I should take. What should be my first step to start trying to simplify the left-hand side? Oh, I see things coming in thick and fast there. Keep them coming. So a lot of people have said change tan. So I think the quotient identity, so you're talking about what I can do over here. And then some other students are saying, what about the square identity that is sitting over here? Yes. See, no, I agree. So what I'm going to do is I'm going to change this to 1. And then what I'm going to do is I'm also going to change the tan squared theta to sine squared theta over cos squared theta. And this is exactly the same as the thing above, except I've changed everything in terms of I've used the identities. Give me a thumbs up if you understand how I did that substitution. Give me a thumbs down if you can't follow what I did there. All right, fantastic. Now, it's time to carry on the journey. I want to know if I want to get to simplify this further. I'm kind of a bit stuck at this block. Does anybody have any ideas about if I look at the other side, there's only one term on the right-hand side. I have 2 separate terms here. I'd love to, artificially glue them together. And I can't glue them together because I don't have scissors. But maybe there's some mathematical way that I can bring these 2 together. Does anybody have an idea that you can think about there? How can I stick these 2 together? I'll give you one other hint. I can write 1 as 1 over 1. I'd love to hear someone's voice if you're feeling brave. Who feels like they have a suggestion? Haruki, let's go to you.
So I might be wrong, but I think based on the activity we did before,
Yes.
since you told me that we could add the cos x by timesing it, I was thinking we do the same here.
You are winning at life. Okay, am I hearing you correctly that I times the top and bottom by cos squared theta?
Yes, sir.
Is that kind of like in the previous one? Okay, I think that's a fantastic idea. So let's do that. And then let's write out what I have here. Now, why is that so useful?
Because now we can turn it.
You can.
We can.
So I think the denominators are the same. I'm not sure if I lost you on the line there, but the denominators are the same. So that can be cos squared theta. And over here, I'm going to have cos squared theta plus sine squared theta. Now, we're almost there. Who has a suggestion for my final 2 steps, or my final step? Who would like to help us along this journey? Let's go to Oyisa.
Hi, sir.
Hey.
I think we could change cos square theta plus sine square theta to 1 because it's an identity.
You are completely correct. And now What do you notice about this 1 over cos squared theta? If I look back to earlier in the question. What's special, or what do you notice that looks familiar? This. So the numerator is 1. Well, let's go to Oyisa. I'll unmute you there quickly. What do you notice about the 1 over cos squared theta?
That the right hand side is equals to the left hand side.
Yep, full marks for you and me. So that's how the question works. Thank you so much, Oyisa. So guys and girls, in the second half of the lesson, we're going to take a break in a moment. But in the second half of the lesson, we are going to practice these types of questions where we work with the left-hand side and we try and make them look like the right-hand side. And I just want to review what is it that we did here. The main steps that we did was we were definitely using substitution. I can see you're getting quite good at that. So substitution was when I replaced like sine squared theta plus cos squared, or I replaced tan. So you're pretty good at that. We also made common denominators. And when we make a common denominator, we basically artificially make sure that both denominators are the same. And the way we do that is by timesing the top and bottom of one of the fractions by the same thing. Okay. And that's the main ideas that I see coming through. I see Haruki has another question. Let me go back to you. Haruki, do you have another question? Well, we're good. Okay, maybe there's just a thing there. All right. Annie's asked, do we always work on the left-hand side? Annie, we don't. It depends on what is the most difficult side, generally. So we work with the one that's harder to make it look more like the other side, which is simpler. Sometimes you have to work with both sides separately, but most of the time you choose one side, work with it, and make it look like the simple side. Okay, so I hope that's helpful. All right, everyone, we've been working hard. It's time for a break. So I want you to turn on your cameras and I want you to stand up. I want Kiwetswe to see us at our phones now, because you know what time it is. It's time to look like this happy chap and have a brain break. So on your feet, let's do it. Let's do it. And let me stand up. Oh, wait, that's too much. Okay, what are we going to do? We're going to start by just swinging our arms a little bit. Take a nice deep breath. There we go. Okay, now what I want you to do is I want you to stretch your arms across. Hold 1, 2, 3, 4, 5. To the other side. 2, 3, 4, 5. Okay. Now what I want you to do is I want you to take your right hand and put it on your nose, and your left hand and put it on your ear. And now what you're going to do is that the hand on your nose is going to reappear on your other ear, and this is going to appear on your nose. So see if you can switch. And then see if you can switch back. And then see if you can switch back again. And if you've really got this, if your brain has figured it all out, you can switch back and forth. And now your brain can talk from the left-hand side to the right-hand side. Well done. Okay, let us do a high heart rate activity. So I've thought about exercises, but you can't beat the jumping jack. So we're going to do 10 jumping jacks. So make sure the space around you is clear, that you don't whack anyone. And we'll start in 3, 2, 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And your exercise class is over for now. So for the second part of the brain break, I want to see, can you make 24 using these 4 numbers? So can you make 24 using all 4 numbers, only plus, minus, times, and divide? Who is feeling like they've got it? And Kate, I see your question. I'll come back to that when I'm on the examples again. Now, yeah. How could we get to 24? This is a bit of a tricky one. So Inga said 7 times 5. So let's try that. So 7 times 5 is 35. And then 35 minus 8 would be 27. No, sorry, 20, yes. And then minus 1 would be 26. It's close, Inga, but it's not quite there yet. But you're close. What about, here's a suggestion. What if you go 8 minus 5? See if that can help you get to 24. If you go 8 minus 5. Who thinks they can get this? So Oris gets 22. That's fine. Oris, you're getting close. So just keep going. So if you've got 8 minus 5, we get 3. 4 times 8. So Nati, you are pretty much there, but where did you get the 4 from? Because there's no 4 on the card. So because there's no 4 that I can see, unless 4 times 8. Yeah, so you need a way to get 4 first. So I think, so Sino says 8 minus 5 times 3. So 8 minus 5 gives you 3. But, oh, Annie, I think you might be onto something. So it said 8 minus 5 is 3. And then I'm going to go 7 plus 1 is 8. And then I'm just going to say 3 times 8 is 24. Or if you wanted to do it in one step, you'd go 8 minus 5 times 7 plus 1, which gives you 24. Aha. So one of the rules, I know that some of you, I haven't played Maths 24 with you before, but you have to use all 4 numbers, and you're only allowed to use those 4 numbers to get to 24. That's kind of how the game works. Okay. But we'll play it a couple of times, and you'll see each time you play it, you'll get a bit better. And it's great for just getting better at sort of mental multiplication and division and stuff. Okay, but it is time to return to the topic of the day, which is trig identity questions. So here are some tips that you can think about. We're not going to go through them in super detail, but I'll paraphrase them for you. Basically, you choose either the left-hand side or the right-hand side to work with. If both sides look difficult, work with both. So normally you would choose one of them and make it look like the other, or you can work with each of them separately and try and make them equal to each other. These 2 steps are talking about substitution. And the 2 main things that you can substitute are the quotient identity and the square identity. Sometimes finding a common denominator is helpful, as we have seen today, so denominator. And sometimes being able to factorize can also be helpful. And so this is just, if you want to take a screenshot of this little checklist, you can do that now, or you can come back to the video later. But often the best way to learn this is just by using it in examples. So that's what I'm going to do, but I'll just show you this list as a quick kind of guideline. Okay, so take a screenshot if you want, and then we'll move on. Okay, so here is question number 1. I want you to identify the harder of the 2 sides And then I want you to try and work with the left-hand side and make, well, okay, I've given a bit of away there, but see if you can work with one of the sides to make it look like the other side. Off you go. And then I will answer any question. If you are confused about something, now is a great time to ask a question while the class is practicing this. Okay. I've gone back a little bit there, Annie and Lutando. I hope that that's helpful. So see if you can, which side would you choose for this example question? Where would you start? That's your first decision. Yeah, Zanele, let's go to you. Zanele, what is your question? Can you hear me, Zanele? We seem to be having some audio issues. You can put it in the chat otherwise if you want to ask your question or the audio is not working. Let's go to Umta. Hi, Umta.
Sir?
Yes.
If you have, I can't explain. If you have, like, you see the left-hand side on it?
Yeah.
I changed 10. So can I move cos to be next to sine?
Okay, let's do this one step at a time. Did you do this, Umta? Did you replace?
Yes.
Okay, fantastic. So you've chosen the right side to work with, and now you've made a substitution. So you've probably already got like 2 marks in the bag. What do you think is the next step that I'm going to have to do?
That's the thing, sir. I was asking, can you move 10, can you move cos to be next to sine, like before sine?
Okay, here's what you can do. You can write this as sine squared x over cos x plus cos x. Does that make sense, Umta?
No, sir.
Okay, so what I did was I said I've got a sine x here, and I multiplied it by the sine x here. You can think about this sine x as being sine x over 1. So if you've got 2 things and you multiply them together, you get the square. The cos x just stayed on the bottom. So, okay, so that will help you. I want to give some more time for students to carry on. What do you think is the next step after that? I'll give you more time.
So, sir,
Okay.
you can also put cos x over 1.
Yes, you can. I call it the one that helps us with fractions. Yes. Okay, and now I see the chat. Thanks, Umta, that was fantastic. Lots of students, Lutando, yes, we're proving again. And Ora and Regile, Chagavatso, they're saying we need to make a common denominator. What would we really like our common denominator to be in this one? What would we really like our common denominator to be? Who has an idea? Because you need to know what you want if you want to make it. And I can make some things happen, but I want to know what I must make. Annie, what do you think I must make?
Sir, I think cos x should be the lowest common denominator.
Okay, how do I make it? How do I make it?
You multiply the 1 by cos x, and then what you do at the bottom, you also do at the top.
Yep, that's exactly what we do. And so then we get sine squared x over cos x plus cos squared x over cos x. Is that what you were suggesting?
Yes, sir.
Okay, now what do you think we have to do next?
So since the denominators are the same, we can write it as sine squared x plus cos squared x over cos x.
That's it. So we can do that. And you've done so well. What's the next step after that?
The sine squared x plus cos squared x will become 1 over cos squared x, which is equal to the right-hand side.
Yep, that's it. So you've got all 6 marks in the bag there. Well done. So you can see that even though this lesson started off quite tricky, these are quite predictable in some ways. Okay. And so all you need to do is enough practice of the different types of tricks that you need to learn about, and it becomes a bit easier. So can I do another quick little check? If you're feeling like you're genuinely following what's going on, give me a thumbs up. If you feel completely lost, give it a thumbs down. I'm just curious to know, I know this is a bit of an abstract section, but I just wanted to get a feel for how you guys are, how it's going. Okay, let me find another question that I can do here. Let's have a look. All right, fantastic. Okay, so then let me see if I can find the right type of question for this. Let's see if I can do, not that one, not that one. Okay, let's try. This is going to be a bit of a tricky one, but we're going to try to end it with this one, and I'm sure together as a group we can do it. So if we start with this question, we are going to try and prove that the left-hand side is equal to the right-hand side. Which of the two sides do you think looks the most tasty? Definitely the left-hand side, yeah. Okay, so let's start by working with the left-hand side, because to be honest, even I don't know exactly what we're going to do, but I know that I'm going to start trying to break down what's on the left-hand side. What part of the left-hand side do you think I can break down first? Or what's the only thing that you think I can break down at this stage? Yeah. So it feels to me like in this jungle of options, the only thing I can really change is the tan x. Mbali, Annie, Tuvatso, you all agree. And so what we would have is we would have this over here in the one bracket, and then this over here in the other bracket. So that was me just rewriting it. Okay, now, I'd really like these two to interact, but the problem I have is that at the moment, I don't really know what to do, but I think maybe I can make these two come together a little bit. How am I going to make these two come together? Yeah, so I think that a good step here would be to say, look, I'm going to times the top and bottom by something. What am I going to times the top and bottom by? Yeah, cos x. Yeah, because I want it to be the same. So I then get, let's say I get cos x sine x over cos x. And this is this whole big bracket here. I haven't touched this one over here yet. Now, if you followed the logic up to that step, this is a much harder question. So just to kind of show you, you've already got 2 to 3 marks already. Okay, now, the next step is going to be just to put these together and go, okay, I've got cos x times sine x plus sine x. And then over here, I've got that. Let's just pause and take a moment to see what I'm doing. If you notice in this step, I had forced it to have the same denominator. That's why all of a sudden I can knit these two together. This part over here is kind of like left out of the action, right? It's still there, it hasn't changed, but I'm ignoring it. Now, this is the difficult step. What can I do? There's nothing I can do here. There's nothing I can do here. There's nothing I can do here. What can I do on the numerator of this part here? What can I do of that part? Who has an idea? What technique that I haven't? Yes, Mbali and Zanele. Wow, that is fantastic. There's a sin x here and a sin x here. So if you do this, you can take out a sin x. Let me draw your attention to it. There's a sin x here and a sin x here. I want to know what, if I factorize and I take out the sin x, would you agree with me that there has to be a cos x here? What am I going to add to that cos x? I'm going to add 1, yeah, because there's a phantom 1 sitting in front here. Okay, we're almost done. This is a really tough one to end the day on, but we can do it. This is being multiplied by sin x over 1 plus cos x. Okay, here's the interesting thing, ladies and gentlemen. What do you spot about this and this? What do you spot about that and that? They're the same. So cos x plus 1 is the same as 1 plus cos x. They are exactly the same. And because they're being multiplied, I can cancel these two out. Yes, we will cancel. Okay, now, I want to know from the class, we're not there yet, but I'm going to go take a look. We started with the left-hand side. We're trying to get the right-hand side. And all we've got left is sin x over cos x times sin x. What do I still need to do to get to the right-hand side? Who has some ideas? So Bonolo has said, change the identity back to tan. And Oyisa, I think you probably are saying the same thing. So we've recognized that this is tan x and this is sin x. And we can then write that as sin x times tan x, which is then equal to the right-hand side. And then we have got all the marks in the bag. Now, that was a pretty tough one. So let's take a moment to review it, to understand the steps we went through. Because trig identities are really about steps. Step 1 was identify the correct side, left-hand side. Step 2, so I'll say, I'll put here, identify. Step 2 was to substitute. I substituted in for tan. Step 3 was using a common denominator, which was this bit of action around here. And then step 4 was to factorize and cancel. And then step 5 was to sub again, where I subbed sin x over cos x back to tan x. And so basically I was just applying those types of steps. Ayanda was asked, in step 1, how did you get the common denominator? So in step 1, if I pull out what was said there, I had sin x plus sin x over cos x. And at that stage, I really wanted these two fractions to have the same denominator. And so I times the top by cos x and the bottom by cos x. And if I did that, I then got cos x times sine x over cos x plus sine x over cos x. And that meant I now have those lovely denominators I was so keen on. Okay, so I hope that is helpful. Can I ask you, Kiretsuwe, to put the link to the quiz in the chat? We're just about finished for today. And what I want to say is this, if you felt a bit unsure today, don't worry at all. This is about as hard as grade 11 trig identities get. So we really have climbed the mountain. If you need to go back and watch this, that is completely normal. So watching this one more time, again on the recording, is probably a good thing to do. And just well done for today's lesson. I really felt like you guys worked really well.